All right, so this is day 16, and today we are going to cover auxiliary views. So let's take a look at the auxiliary views. So why do we use auxiliary views? So basically, you have inclined lines and orthographic views, and those inclined lines are foreshortened, which means that the dimensions that they have kind of in those normal three front, top, right orthographic views aren't necessarily the best way to describe what those dimensions are because they're foreshortened. So with that, what foreshortened means is that the dimensions, as we just said, kind of the dimensions that appear. So you can see that the dimension, the little red arrows that go back and forth, they're not all the same length. And because of that, you can't really accurately describe that dimension, right? Because we don't know what is the true length of that side. So there are better ways to show those dimensions of those inclined lines, and that's with an auxiliary view. So basically what you can do here is you can take the inclined line and look normal to that surface. So you're looking, that surface is perpendicular with your line of sight. And we can do that by see how we can kind of drag off and see that true surface. What that's going to let us do is it's going to let us dimension things that are on that surface. So if you have features, like a little hole coming through or maybe something on top, maybe some buttons or something like that, like imagine a blender with buttons, right? We need to define where those buttons are on that blender, and it might be on that inclined surface. Random example, but you know what I mean. Basically, we have this true surface now, and so we can dimension things as they would be on that true surface. It makes dimensioning things on inclined lines easier. So auxiliary views, they're drawn parallel to the surface that they're coming off of. And they can be projected from any view. So basically, whatever lines make sense. Wherever that inclined line is what you can draw the auxiliary view off of. You just need it to be parallel to that inclined line. So how do we draw an auxiliary view? So we start by drawing projection lines off of it that it needs to be projected from. So you see those lines that come straight off. The lines that hit the auxiliary, that face itself, are going to be at 90 degrees, right? Because we're looking normal to that face. And all the other lines come off. We're going to see this in the example. It'll make a little more sense what we're doing here. But these lines are perpendicular to the edge, and the projection lines, you draw them really light because not all of them are going to be kept, and you need to erase some of them. So we're not going to use all of them later. So draw them very light. So how to draw an auxiliary view, and then you're going to use the dimensions from the side. So basically, it's a little blurry here, but we'll see in the example in a minute. You're going to reuse the depth dimensions from the in this example, the top view, and that's going to give you some of your dimensions. And the other dimensions are going to stay because you're bringing those lines straight across. So another thing to note is that there's because this is technically like a normal view, it's similar to any top, front, and right view, right? It's not an isometric view, and because of that, we're going to keep hidden lines visible. So basically, that back edge, that red line that we see, there's going to be a hidden line back there. And it's going to be, I'm saying this hidden line is visible, but we're including it is what I mean. So we need to make sure we're including the correct hidden lines that are now hidden from this. So that's really the thing that trips people up most. But otherwise, it's pretty easy to get the hang of. So let's do an example together in a second. Another quick thing is that the orthographically, if you see an ellipse, if that circle is normal to the surface, that's going to be a perfect circle in your auxiliary view, right? And so you can, it's a little easier. Same thing, other way around with, going the other way from that. And then just some quick notes on center lines and center marks. You only show a center mark if you're normal to that circle, right? If you're looking down that circle and you can't see the walls of it because you're perfectly normal to it, that's the only time you show center marks. Otherwise, you're going to show a center line, showing that there's a cylinder cut through there. But yeah, that's it. Let's take a look at this